Hi, good morning. സോ ഉച്ച കഴിഞ്ഞിട്ട് വൈവയുടെ കാര്യം ഓർമ്മയുണ്ടല്ലോ. 6th അവർ 21 മുതൽ റോൾ നമ്പർ. സോ 20 ആളെ കംപ്ലീറ്റ് ചെയ്യാൻ പറ്റുമെന്ന് അറിയില്ല, എങ്കിലും ജോയിൻ ചെയ്ത് നോക്കുക ഈ പറഞ്ഞിരിക്കുന്ന ആൾക്കാർ. ഓക്കെ, സോ നമുക്ക് സ്റ്റാർട്ട് ചെയ്യാം. ഓക്കെ, so in our previous class we discussed about PN junction diodes. Basic device or basic unit behind all the solid state devices or the semiconductor devices are PN junction diode. So it is a connection between P type semiconductor and N type semiconductor. In our previous class we discussed about how a PN junction is formed and what you mean by majority carriers and what you mean by minority carriers, then carrier recombination. Then we discussed about what is depletion region, barrier potential, forward biasing, reverse biasing, so, and electron hole pair forming recombination. So all these terms, technical terms, are discussed above, and we studied what you mean by that, what you mean by carrier recombination or electron hole pair formation. So these processes, these technical terms are needed to explain or define the working of uh, electronic devices such as LED, photodetectors such as photodiode, pin photodiode, and solar cell. സോ നമ്മൾ നിങ്ങളുടെ ഈ സിലബസിൽ പഠിക്കുന്നത് നാലോ അഞ്ചോ കാര്യങ്ങളാണ്. ഇത് LED, photodetector, solar cell. So in order to describe or define, explain these things, we need to know what happens in a PN junction diode or what happens if we apply a potential to a PN junction diode. Okay, the basic PN junction diode basic കാര്യങ്ങളിലേക്ക് ഇന്ന് പോകുന്നില്ല. Initially, what do you mean by photonics? It is also explained yesterday. Photonics is the physical science of light waves, or it deals with the science behind the generation, detection, and manipulation of light. It means in devices such as LED or laser, the light is generated there, or detection. What do you mean by detection? The light or light waves is detected using these solid state devices such as photodetectors or photodiodes. And manipulation of light, what do you mean by manipulation of light? Manipulation of light means we can change or we can tune the properties of light waves produced by an equipment or a device by certain arrangements. Specifically speaking, by creating some alloys or by doping semiconductor, we can define what should be the light wavelength of or the frequency of light emitted by laser built by such a semiconductor. നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും? ലൈറ്റ് എമിറ്റ് ചെയ്യുന്ന അല്ലെ ഡിറ്റക്ട് ചെയ്യുന്ന എക്യുപ്മെന്റിന്റെ പ്രോപ്പർട്ടീസിനെ engineer ചെയ്യാൻ പറ്റും, or we can tune the properties of that material. That is how we can control or manipulate the properties of light detected or emitted by it. Okay, so that is all about photonics. So just photonics is just study of light or study of propagation of light through certain material, or how we can generate, detect, or manipulate light. വിശ്രുത രഞ്ജിത്ത് ബാബു ഇടയ്ക്ക് ലീവ് ആവുന്ന എനിക്ക് കാണുന്നുണ്ട്. സോ അങ്ങനെയുള്ളവർക്ക് അറ്റൻഡൻസ് തരാൻ പോസിബിൾ അല്ല. സോ ലൈറ്റ് എമിറ്റിംഗ് ഡയോഡ്. First one, for the first topic we want to discuss is light emitting diode. What is a light emitting diode? It is a forward bias PN junction. So what happens if a PN junction is forward bias? What do you mean by forward bias? Forward biasing means connecting the P side of a PN junction with the positive terminal of cell or battery, or don't care about it whether which power source here connect the positive electrode of this power source to the p side of a p-n junction and n side of a semiconductor, or n-type material is connected to the negative terminal of a battery. Such an arrangement or circuit can be called as forward biasing. So what happens when we forward bias a semiconductor? When forward biasing a semiconductor, or 1 minute, before forward biasing, before we applying this potential or before we connecting this circuit, before that there are majority carriers called electrons in n side, also majority carriers holes in the p side, and yesterday we discussed that there will be a depletion region or a barrier potential here. So majority carriers electrons in the n side is not able to pass this barrier junction or barrier potential. Why? Because it has low energy, or it doesn't have energy to cover or just pass this barrier potential or depletion region. But when we apply a for forward bias, or when we connect this circuit as a forward bias circuit, what happens? Now the electrons will move, or a current will be developed in this circuit, or the electrons will move through this n region, or vice versa. We can say that holes which is positively charged will move to this p side material. So what happens? The density of electron will increase in this area, or we can say energy of electron in this side or n side, the energy of electrons which are majority carriers will increase. So what happens if the energy of majority carriers increase? Now if the energy is greater than the barrier potential here, the energy of electron is greater than the barrier potential in this depletion region. Now what happens? Then these electrons, which is majority carriers, will pass through this depletion region to reach the p side, or uh, taking the case of holes, these holes which have higher energy can move towards this region. So what happens? So ഈ n സൈഡിലുള്ള ഇലക്ട്രോൺ ഈ സൈഡിലേക്ക് മൂവ് ചെയ്യും, p സൈഡിലുള്ള ഇലക്ട്രോൺ ഈ സൈഡിലേക്ക് മൂവ് ചെയ്യും. So what happens? So between these two sides the electrons and holes will meet, or what happens? There occurs carrier recombination, for this electron and hole will, let's say, collide or meet up, and they recombine each other. Electron hole recombine because they are opposite charged particles. And what do you mean by hole? Hole is just void of an electron. Void of an electron. അതായത് ഇലക്ട്രോൺ ഒരു സ്പേസിൽ നിന്ന് മൂവ് ചെയ്ത് കഴിഞ്ഞാൽ the remaining polarity is defined as hole. So what do you mean by electron hole recombination? That means electron go and just electron is reached back to the void, or electron complete the void which is remained by another electron. So what happens here? Electron hole recombination happens here, and extra energy of this recombination will emit as light. The individual energy of this electron and hole is less than that of this an electron hole pair. So there will be an extra energy in happens, or there will be an extra energy here in the case of recombination. So what happens? This extra energy will give us, or will give us light energy. ഈ extra energy എന്ത് ലൈറ്റ് എനർജി ആയിട്ട് എമിറ്റ് ചെയ്യപ്പെടും. ഓക്കെ, സോ ഞാൻ മുമ്പ് പറഞ്ഞ തെറ്റെങ്കിൽ ഒന്നും കൂടി പറയാം. When hole and electron, that means majority carriers in p side and n side, recombine each other, what happens? The individual energy of this electron and hole is, അതായത് ഈ ഇലക്ട്രോണിന്റെയും ഹോളിന്റെയും എനർജി സമ്മപ്പ് ചെയ്താൽ എന്താണ്? It should be greater than the energy of this electron hole pair, or the energy of recombined electron hole pair. So that means now the energy of electron hole pair should have lesser energy than the sum of the individual energies. That means if the recombination happens, some energy should be emitted through the surrounding. This energy is emitted as light energy, or in terms of photon, or we can say this energy is converted into photons or electromagnetic waves, which is light waves will travel from this depletion region. So this is why an LED or a forward biased PN junction give light as the result of forward biasing. So we discussed how an LED. What do you mean by LED? LED is just perfectly engineered PN junction diode. When a PN junction diode is forward biased, or mean P side is connected to positive terminal and N side to negative terminal, carrier recombination takes place when the potential contributed by, if the potential of this cell or the potential offered by this cell is greater than the barrier potential. If the potential of this cell is greater than the barrier potential, what happens? This majority carriers electrons will have energy to cover this barrier potential. So what happens if these majority carriers travel across this junction? Carrier recombination takes place and extra energy is given off as light, and this is how light is emitted from a light emitting diode. Okay, and what are the major uses of L- this LED, light emitting diode? Major uses എന്താണ്? We know that light emitting diodes are used as a power indicator. One of the important use or the advantage of LED is, one of initial one is, it is cost effective. So in order to produce light, we don't need to heat up a filament. That means, or we don't want to apply a potential between some cathode ray tube അല്ലെങ്കിൽ ഒരു gaseous സ്പേസിൽ എന്താണ് ഇപ്പം ഫോർ എക്സാമ്പിൾ CFL അല്ലെങ്കിൽ ട്യൂബ് ലൈറ്റ് പോലെ നമ്മൾ ഹൈ എനർജി കൊടുക്കേണ്ട ആവശ്യമില്ല. ഓർ ടേക്ക് ദ കേസ് ഓഫ് ആൻ ഇൻകാൻഡസെന്റ് ബൾബ്, a lot of heat will be lost as a lot of energy will lose as heat energy. But in case of an LED, it is cost effective, and energy efficient, because a small amount of energy is given, that some 1 to 3 volt is needed to, normally the voltage rating of LED is between 1 to 3 volts. So a low amount of energy is needed to uh, work, or needed for an LED to work. Okay, and one of the uses is it is cost effective and it can be used as a power indicator. What do you mean by power indicator? You have seen in your televisions, mobile phone, and all electronic equipments, power indicator means it says whether the electronic equipment is working or on or off. നമ്മുടെ ടി വിയിൽ മൊബൈലിലൊക്കെ പവർ ഇൻഡിക്കേറ്റർ എന്ന് പറയുന്നത് ചെറിയൊരു LED ബൾബ് ചുവന്ന കളറിൽ കാണാറില്ലേ, അതായത് ഡിവൈസ് ഓൺ ആണോ ഓഫ് ആണോ എന്നറിയിക്കാൻ വേണ്ടിയിട്ടുള്ള സംഭവം. സോ LEDs are widely used as power indicators. And also we know in digital watches and all other 7 segment display, that means we have 1 2 3 4 5 6 7. So if we have 7 LEDs, നമുക്ക് 7 LED ഉണ്ടെങ്കിൽ we can display any number. So നിങ്ങളുടെ വാച്ചുകളിലൊക്കെ ഇതാണ് കാണുന്നത്. If we have 7 LEDs, we can display any number. That means if 7 LEDs are in on state, it represent 8. Consider that is 7 LED എന്താണ്, consider 1 LED is off, then it represent 9. So using this 7 LED segment display, it is called 7 segment display. 7 segment display. Okay, so we discussed what are the how light is emitted from an light emitting diode. It is just a simple PN junction diode which is forward biased, and how light is emitted and what are the advantages and what are the major uses of this LED. Now we are moving to our next topic, photodetectors. What do you mean by photodetectors? The name itself say they are photodetectors, or they are light detectors. So photo detector say, or some light detector predicts whether there is a light in this some area. അതായത് ഒരു സ്ഥലത്ത് if we want to know whether light is present or not, we can use photo detectors as sensors. Or if we want to measure the amount of light in certain region, or measure the intensity of light in certain region, just using photo detectors we can measure the amount of light. Okay, what is photo detectors? What is the working principle of photo detectors? Photo detectors are really reverse biased PN junction diode. I'm talking about photodiodes. Okay, so the function of photo detector is to detect light or detect photons, and they are basically reverse biased PN junction diode. What happens when a diode That means when a PN junction diode is reverse biased. When a PN junction diode is reverse biased, we know that the width of depletion region will increase. ഇതൊക്കെ നമ്മൾ ഇന്നലെ എക്സ്പ്ലെയിൻ ചെയ്തതാണ്. വാട്ട് യു മീൻ ബൈ റിവേഴ്സ് ബയാസിങ്? Reverse biasing. Reverse biasing means connecting the P side of the PN junction diode into to the negative terminal and N side into positive terminal. So what happens? This holes, majority carriers in P side, will get attracted to this negative terminal, and these electrons in which are majority carriers in N side will get attracted to this positive terminal. So what happens? So due to this, the depletion region, the width of depletion region will increase, and there will be thermally excited electron hole pairs. Normally we know that normally these photodetectors or photodiodes works under room temperature, or normally as some say normally at room temperature. That means at least 300 Kelvin. And we know 300 Kelvin is a high temperature according to materials. 300 Kelvin എന്നൊക്കെ പറഞ്ഞു കഴിഞ്ഞാൽ വളരെ വലിയ temperature ആണ്. So atoms and molecule will possess energy. So due to this thermal energy, what happens? A small amount or a tiny amount of electron hole pairs are produced in this depletion region. So if we apply some voltage, we can measure or we can observe a tiny amount of current or reverse current is flowing through this circuit. That means in a reverse biased PN junction diode. Okay. So a tiny amount of current will flow through this circuit in a PN junction diode. And this current, when no light is incident on this depletion region, is known as dark current. Okay, so what is a photodiode? So photodetector is a general topic. Photodiode is an example for photodetectors. Photodetector means they are equipment, say a semiconductor equipment or an electronic equipment which is used to measure or detect light. Okay, so normally they are PN junction diodes, which is reverse biased. So what happens when a PN junction diode is reverse biased? There will be a small reverse current, or due to thermally generated electron hole pairs, there will be a small reverse current here. Or we can call that as the current due to minority carriers, because here the electrons will be attracted to this P side and holes will be attracted to N side. So electrons are minority carriers here and holes are minority carriers in the N side. So this current or reverse current in a circuit is due to minority carriers. So when light is incident on this depletion region, what happens? So thermally generated ആയ electron hole pair കാരണം ചെറിയ രീതിയിലുള്ള current ഉണ്ട്. പക്ഷേ when light incident on this depletion region, more electron hole pairs will be formed in this depletion region. That means the energy of photon will get converted into the energy, or that energy is used to excite electrons from valence band to hole. Or we can say electron hole pairs are generated in the depletion region of a PN junction diode when light is incident on it. And if electron hole pairs are generated, then what happens? Then we can say the amount of minority current or the amount of current flowing through this circuit increases. So by measuring this amount of current, we can predict what is the intensity of light or what is the amount of light which is fallen on depletion region. So once again, when the photons or the when light waves incident on a depletion region of a PN junction diode, there will be the electron hole pairs are generated. These electron hole pairs will attract to N side and P side of a semiconductor PN junction diode based on the polarity, and this results in a current which is flowing through the circuit. So by measuring this current I, say some IR, ഈ കറണ്ട് മെഷർ ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് പ്രൊഡിക്ട് ചെയ്യാൻ പറ്റും? ബൈ മെഷറിംഗ് ദിസ് കറണ്ട് or the variation of this current, we can measure what is the amount of light or what is the amount of photon which is incident on this depletion region. Okay, attendance പറഞ്ഞു.
1.
Two
2.
percent.
അല്ല
3.
2%.
3.
4. 4%. 5.
5.
6.
7. 8.
9.
10.
11.
12.
13%.
Sir, 13%.
14.
15.
16%.
16. 17.
18.
19.
20.
21.
22.
23%.
24.
25.
26.
27.
28.
29.
30. 31.
32.
33.
34.
35.
36.
37.
38.
39.
40.
41.
42.
43.
44.
45. 46.
47.
48.
49.
50%.
51.
52. 53. 54. 55. 56. 57.
58.
59.
60.
61.
62. 63.
63.
ഓക്കെ. ഈ ലെഫ്റ്റ് അടിക്കുന്നൊക്കെ കറക്റ്റ് കാണുന്നുണ്ട്. അങ്ങനെയുള്ളവർക്കൊന്നും അറ്റൻഡൻസ് തരാൻ പറ്റൂല. ഓക്കെ, സോ തിരിച്ചു പോവാം. കാണാം. സോ നമ്മൾ സംസാരിച്ചുകൊണ്ടിരുന്നത് എന്തിനെ കുറിച്ചായിരുന്നു? Photodiode. So what happens in a photodiode? Normally photodiode means or just it is a type of photo detector. In a photodiode, it can be said as a reverse biased PN junction. So what happens when light is incident on a reverse biased PN junction? Due to this reverse bias, a wide depletion region will be formed in this PN junction. So when light is incident on this depletion region, electron hole pairs will be formed due to the absorption of energy from this light or the photon. When electron hole pairs are formed, it gets attracted to p side and n side based on the polarity. So we can say that a current will be produced or developed in the circuit. So by measuring this current, we can calculate or we can detect the amount of or intensity of light incident on this depletion region. So light depletion region incident ചെയ്യുമ്പം കറസ്പോണ്ടിംഗ്ലി കറണ്ട് ഉണ്ടാവും. ആ കറണ്ട് മെഷർ ചെയ്തിട്ട് നമുക്ക് പറയാം എത്ര ലൈറ്റ് ഫോട്ടോ ഡയോഡിൽ ഇൻസിഡന്റ് ചെയ്തു എന്ന്. ഓക്കെ, റിലേറ്റിംഗ് ടു ദാറ്റ്, one of the special type of photodiode is pin photodiode. So normally we know that generally we know that a photodiode is a PN junction, a reverse biased PN junction. PN junction. What do you mean by pin photodiode? So when reverse biasing, what happens? We know a wide depletion region is formed. So the width of depletion region, that means look at here, the width of depletion region of a PN junction, it is dependent, or it determines how much light should be incident on this PN junction diode. അതുകൊണ്ട് പി എൻ ജംഗ്ഷൻ ഡയോഡിന്റെ ഡിപ്ലീഷൻ റീജിയനിൽ ഇൻസിഡന്റ് ചെയ്യുന്ന ലൈറ്റ് മാത്രമേ എന്ത് ചെയ്യുന്നുള്ളൂ? ഇലക്ട്രോൺ ഹോൾ പെയർ ഉണ്ടാക്കുന്നുള്ളൂ. That means only light waves which get incident on the depletion region of PN junction diode only creates electron hole pair. Or we can say the light incident on the depletion region of a PN junction diode only contributes to the current produced in the circuit. So we can say that, so there will be a necessity, that means depletion region should be very wide. Depletion region width കൂടുന്നതനുസരിച്ച് എന്ത് കൂടും? അതിൽ ഇൻസിഡന്റ് ചെയ്യുന്ന ലൈറ്റ് കൂടും. Okay, so in order to achieve that thing, we made a new, or we are going to study a new topic, that is pin photodiode. And the main advantage of pin photodiode is depletion region of a pin photodiode is very wide when compared to a normal PN junction photodiode. That means an intrinsic semiconductor, an intrinsic type of semiconductor. Fatima Sohara, ഞാൻ പറഞ്ഞു ലെഫ്റ്റ് അടിക്കുന്നവർക്ക് അറ്റൻഡൻസ് തരൂലെന്ന്, വെറുതെ പറയുന്നതല്ല. Okay, we know normally we have a p-type semiconductor, n-type semiconductor. In a pin photodiode, an intrinsic type semiconductor. What do you mean by intrinsic semiconductor? Intrinsic semiconductor means, intrinsic semiconductor is just pure semiconductor, or we can say it is an undoped semiconductor. So we place an intrinsic semiconductor between this PN junction diode. So what happens then? Normally when sandwiching these two, these three materials, or connecting p-type semiconductor, intrinsic semiconductor, and n-type semiconductor, what happens? We know when in the PN junction, what happens when a PN junction is formed? Similar to that, there will be negative immobile atoms will be created here, and positive immobile atoms or pentavalent atoms are created here. Then what happens? Then an electric field is created here. So that means a depletion region is formed between n-type semiconductor and p-type semiconductor. Now, due to this presence of intrinsic semiconductor or pure semiconductor, the width of the depletion region, ഈ ഒരു കേസിൽ ഡിപ്ലേഷൻ റീജിയന്റെ width നിങ്ങൾ ശ്രദ്ധിച്ചു പോവുക. Now the width of the depletion region is increased, or it depends upon what is the width of this intrinsic semiconductor. So now the width of this depletion region increased, that means more light get absorbed in this material. So this is why this photodiode or this electronic equipment is called pin photodiode. Pin എന്ന് പറയുന്നത് p-type, intrinsic and n-type. So connecting p-type semiconductor, intrinsic and n-type semiconductor in this way will result in a high depletion region, or we can say now we get a wide depletion region or intrinsic region. So what is the benefit of having a wide depletion region? That means more light get incident on this wide depletion region. So normally photodiode is a photodetector. It gives us what is the amount of light incidenting on this electronic equipment. So using a pin photodiode, it enables us to have a wide depletion region. So wide depletion region means, the benefit of having wide depletion region means more amount of light get incident on this material. That means more amount of light, or that means more amount of light means more electron hole pairs are created. That means a large current or more current, increased density or increased amount of current is formed in this circuit. So comparing to a PN junction photodiode, the benefit of photodiode is it have a wide depletion region, so it can absorb a wide amount of light in its surface area. So if that equipment can absorb more amount of light, that means more electron hole pairs are formed in that area. A large amount of electron hole pairs are formed. What is the benefit of that? That means it gets attracted to the both n-type and p-type semiconductor, and more current or large amount of current will be flow through circuit. So we can measure a large amount of current. So advantage of pin photodiode is it have a high bandwidth. That means light in the old light in case of all the frequency. That means a wide bandwidth. It can absorb a light of a bland and sorry, it can absorb light with high bandwidth. അതായത് ഒരുപാട് ഫ്രീക്വൻസിയിലുള്ള ലൈറ്റ് അബ്സോർബ് ചെയ്യാൻ പറ്റും. മെയിൻ ഡിഫറൻസ് ബിറ്റ്വീൻ എ ഫോട്ടോ ഡയോഡ് ആൻഡ് എ pin photodiode. Okay, now we are moving to these are the advantages of pin photodiode. നമ്മൾ പറഞ്ഞാണ് it has a wide bandwidth, high efficiency, high response speed, and they will generate more electric current than PN junction photodiode with same amount of light energy. That means if we have same amount of light energy, due to the change in or the difference in the width of depletion region, the pin photodiode is able to produce more current or produce more electron hole pairs. Now, as a last topic, we are discussing about solar cell. What is a solar cell? Solar cell എന്ന് പറഞ്ഞാൽ എന്താണ്? So here it says that solar cell is an LED operating in reverse method. So how a LED works? We described that LED is a forward biased PN junction. LED is a forward biased PN junction. So in an LED, what happens? When we apply potential or when we apply some electric field, or let's say when we apply potential which is greater than the barrier potential of the depletion region here, what happens? The current will flow through this material and electron hole recombination takes place, and this extra energy of electron hole recombination is given as light. That is the working principle of the solar cell. It is the reverse operation of an LED, or solar cell can be called as an LED operating in reverse method. So instead of here having a power source, we can connect it with a voltmeter. ഒരു ബാറ്ററിക്ക് വരെ നമ്മൾ എന്ത് ചെയ്യുക, ഒരു വോൾട്ട് മീറ്റർ കണക്ട് ചെയ്യുക. Now incident light on this PN junction. So what happens? So apart from electron hole recombination, take example of photo detector. What happens when light is incident on depletion region? When light gets incident on depletion region, electron hole pairs are formed. So what happens if electron hole pairs are formed? If electron hole pairs are formed, then the holes will be attracted to P side and electrons will get attracted to N side. And it contributes to the current, or it will produce a current in the circuit, and we can detect that potential or current by placing a voltmeter here, or we can detect the EMF produced by a solar cell by placing a voltmeter in the circuit. So what is a solar cell? Solar cell is an LED. Actually, it is a LED operating in reverse method. In a light emitting diode, when applying a potential which is greater than barrier potential, carrier recombination takes place and it is given as light energy. The extra energy is given as light energy. In case of a solar cell, light incident on intrinsic region or depletion region creates electron hole pairs. This electron hole pairs contributes towards the current. In the depletion region, electron hole pairs are formed, or the electron from the valence band are excited to the conduction band, or we can say an electron hole pair is formed when light energy is incident. That means the energy from the photon is transferred to electron in order to excite it from valence band to conduction band. So electron hole pair is produced, a large number of electron hole pairs are produced, and it give rise to a current, and it can be measured using an ammeter, microammeter here, and the potential or the EMF produced by this current or this electron hole pairs is given, can be measured using a voltmeter. ഓക്കെ, സോ ദിസ് ഈസ് ഹൗ എ സോളാർ സെൽ വർക്ക്സ്. എങ്ങനെയാണ് ഒരു LED വർക്ക് ചെയ്യുന്നതെന്ന് മനസ്സിലാക്കിയിരിക്കുക. LED എങ്ങനെയാണോ വർക്ക് ചെയ്യുന്നത്? ഒരു പൊട്ടൻഷ്യൽ കൊടുക്കുമ്പോൾ ഇലക്ട്രോൺ ഹോൾ റീകോമ്പിനേഷൻ നടക്കുന്നു, അതിന്റെ എനർജി ലൈറ്റ് ആയിട്ട് പോകുന്നു. നേരെ തിരിച്ചാലോചിക്കുക, ഹൗ എ സോളാർ സെൽ വർക്ക്സ്. ഹിയർ ദ ലൈറ്റ് ഈസ് ഗിവൺ ത്രൂ ടു എ PN ജംഗ്ഷൻ ഡയോഡ്. ദെൻ റീകോമ്പിനേഷന് പകരം ഇലക്ട്രോൺ ഹോൾ പെയർ ഫോർമേഷൻ നടക്കുന്നു. ദ ഇലക്ട്രോൺ ഹോൾ പെയർ ഫോർമേഷൻ ഹാപ്പൻസ്, and when that formation happens, if electron and hole pair is formed, it will get attracted to p and n side. So that means it will create a potential, or it will contribute, or it will produce a current in the circuit. This is the just a conventional picture used to represent solar cell. This is what I describe about solar cell. What happens when light is incident on the depletion region of a PN junction diode. Okay. Now the minimum photon energy required to produce a current. That means all the energy, if the solar energy or the solar light consists of so many frequencies. That means from 400 to 600 nanometer. So all this frequency can produce a current in the depletion region. It can produce a electron hole pair in the depletion region. Why? Because we know that every material has some band gap. What is band gap? Band gap is the energy gap between conduction band and valence band. So here we have so many electrons in the valence band. So what happens? So when light is incident, say some light with mu frequency is incident on it, then what will be the energy of that photon? It will give A E is H mu. If this energy is greater than this band gap energy, EG, energy electron get excited from this valence band to conduction band in order to create an electron hole pair. But if this energy or the frequency is less than the band gap, is less than EG, then this electron cannot reach this conduction band, or the electron hole pair cannot be created. So in order to create an electron hole pair, or in order to produce current in a circuit, or create a potential difference in the circuit, the incident light should have energy greater than the band gap of semiconductor. PN junction silicon angle, this energy should be greater than the band gap of silicon, or the minimum frequency of light in order to create a potential difference, or in order to produce a current in a solar cell, is given by EG by H, where EG is the band gap, H is the Planck's constant. And at last, this IV characteristic of a solar cell can be determined using this circuit. Passing or produced by the solar cell, and a voltmeter which is connected parallel to or across the solar cell with a resistance. So in order to measure the current produced, or in order to deliver voltage or the current produced in the circuit, we need some resistance. So this is the basic circuit used in a solar, in order to measure the current and voltage. And the IV characteristics of a solar cell looks like this. സോ ഇത് കുറച്ചൊരു 5-10 മിനിറ്റ് പറയാനുണ്ടാവും. സോ ഇന്ന് സമയമില്ല. സോ നമുക്കിത് ബാക്കി നാളെ നോക്കാം. ഓക്കെ. സോ അറ്റൻഡൻസ് ആബ്സെന്റ് ഞാൻ മാർക്ക് ചെയ്തത് നമ്പർ 4 23 50 62.
4% ചാറ്റ് ബോക്സിൽ ഇട്ടിട്ടുണ്ടായിരുന്നു.
ശരി.
23%.
അല്ല, ഈ അറ്റൻഡൻസ് എടുക്കുമ്പോൾ ഈ പറഞ്ഞ ആൾക്കാരൊക്കെ എവിടെ പോയി? ഓക്കെ, നെറ്റ്വർക്ക് പ്രോബ്ലം ആണെങ്കിൽ കുഴപ്പമില്ല, അറിഞ്ഞുകൊണ്ട് ലെഫ്റ്റ് അടിക്കുവാണെങ്കിൽ നമുക്കൊന്നും ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, 50 and 62 ആർ അബ്സെന്റ്. പക്ഷെ സാരെങ്കിലും ഞാൻ കുറച്ച് സമയം കണ്ടിരുന്നു, എന്നിട്ട് ലെഫ്റ്റ് അടിച്ച് പോയതാണോ? 50, റോൾ നമ്പർ 50. ഓക്കെ, ഇല്ല അല്ലേ? ഓക്കെ, എന്നാൽ താങ്ക് യു. നാളെ കാണാം. പിന്നെ വൈവ മറക്കണ്ട, ഉച്ച കഴിഞ്ഞിട്ട്.
Sir.